Hi, good morning, everybody. My name is Lauren Kruszewski, and I am an aerospace engineer out here at Edwards Air Force Base. And I'm here to talk to you guys today about aerospace engineering. So before we kick things off, I wanted to know a little bit more about you guys. So throughout the presentation today, I'm going to be asking you guys a series of poll questions. And so the first one I'm going to ask is just, what grade are you guys in? Where are you at in school? And all that good stuff. And as we also go through the presentation today, there's a text-in number that you guys can go ahead and text in some questions that I will address later on in the presentation. So a little bit about me. I was born in Fort Carson, Colorado. Both of my parents were in the Army, so I had the privilege of moving around 5 times before settling in Chesapeake, Virginia for high school. And throughout my childhood and really now, I've had 3 main passions. So the first being mathematics. Growing up, I loved math. Anything numbers, equations, variables, all of that. Mathematics was really the course that I was passionate about. And that's really followed through as I've continued my career. Oops. All right, hold on, please. Sorry about this. My next passion is airplanes. So growing up, I was always really interested in planes, but it was really more of a fascination. And it wasn't until I saw this plane here, which is the F-22 Nighthawk, that I really wanted to know more about airplanes and how they worked, how they flew, and all of that. So that's what really sparked my interest in pursuing a career in aerospace engineering, was the F-22. And my third passion was golf. So I started playing golf when I was 6, and I played throughout high school and was recruited to play in college. And funny enough, if it wasn't for golf, I would have never found aerospace engineering. So I grew up in a family of medical professionals. I didn't have anyone in my career field that could help me along with the engineering topic. So when I was going to go play golf in college, I had the opportunity to tour universities, both for their athletic facilities and also their academic facilities. And I really started learning about aerospace engineering and all of the awesome career fields that it brought when I was looking to go play college golf. So all that to say, I had no idea what I wanted to do in high school up until probably about my junior and senior year. And that's totally okay if you guys don't know what you want to do just quite yet. So hopefully my spiel today will help teach you a little bit about aerospace engineering. And I'll be happy to field any questions, like I said, with any that come up. So my next question for you guys in the poll is just, who's interested in aerospace engineering? Like I said, I didn't know a lot about it growing up, and now I'm just completely in love with the degree and the discipline. So looking to see for you guys who's interested, and hopefully I can pique your interest a little bit more. So by the book, aerospace engineering is the primary field of engineering concerned with the development of aircraft and spacecraft. And when I hear aircraft and spacecraft, I think, holy cow, you know, your options are endless. You're talking stuff here down in Earth's atmosphere, as well as stuff out in space. And for me, I love both airplanes and space, and I think that's a totally awesome answer. And looking to you guys to see what you're interested in, airplanes, space, or both. So when you talk about both types of engineering, you're really looking at aeronautical and astronautical. There's 2 subgroups of aerospace that you tend to focus on as you advance in your both education and your career. So if we're looking at aeronautical engineering, you've got some pictures there. So I'm a little partial to that mighty Raptor that you see. That's the F-22 down there at the bottom right. But really, aeronautical engineering can span so many different disciplines. The big thing for us is aerodynamics and trying to make things fly. But things that fly can be airplanes, they can be missiles, they can be helicopters. It can really be anything and everything you could think of. Hypersonics is a big discipline that's growing now. So even under the aeronautical engineering branch, there's a lot of paths that you can take to really hone in on what you're passionate about. And similarly for astronautical engineering, right, that's space. So you've got things like rockets and satellites and the space shuttle there. If you guys have ever seen the movie The Martian, and they talk about a rendezvous and space trajectory, that's a problem that I helped solve in one of my courses for orbital mechanics. So whether you like to stay closer to Earth or launch into space, aerospace engineering has a lot of really awesome opportunities and career paths that you can take. And again, if you guys have any questions, feel free to go ahead and text them in as we go through these different engineering disciplines. So for college, what does it look like if you're picking an engineering career field? Normally what you do when you start out is you pick either the aero or the astro side of the house. So we talked about aeronautical engineering and astronautical engineering. You'll pick one of the two going in, but don't fret. That's not something that you're stuck with. So your first 2 years of really any engineering course is going to be more general studies. So they're not necessarily specific to aero or astro. They could really be anything meant to build your technical foundation. So you can try things in propulsion and electrical engineering and software programming. It's really meant to give you guys a taste of all of the different engineering career fields you could choose from and make sure that you picked the right decision. I think what I would really try to advise you guys to do is find what you're passionate about and go ahead and pursue it with all of your heart. There's no need to settle here. And if you have questions and you're not sure if you've picked the right path, there's a lot of mentors and advisors that you can talk to, as well as fellow classmates to help get an idea of what really there is out there for you to study. And in these first 2 years, because it is more of your general technical foundation, you can go ahead and switch focuses during this time frame with minimal penalty. So if aerospace isn't for you, great, you can go ahead and switch. And if it is for you, get really excited for what those next 2 years are going to hold, because that's where the fun really, really happens. You get into what we call your focus-specific courses, where you launch into things like advanced aerodynamics or your space trajectory courses, like I mentioned previously. There's a lot of opportunities and a lot of really cool courses that you get to take that open your eyes to the world of aerospace. One of my most favorite courses was a wind tunnel course where we took a lot of aircraft models in a wind tunnel just to see how they flew. And I thought that was just the coolest thing. Taking small-scale models of an F-22 and of a Boeing 737 and just seeing how incredible these machines are. What your final 2 years will culminate into is what's called a senior design project. So you are launched into a year-long course, and your professor assigns you both requirements and a team. And it's going to be your job as a team to design a new aircraft or spacecraft, depending on which track you take, and to design it, to manufacture it, to test it, and then to report on how successful, hopefully, your design is. And that whole process, that full year-long process, is a very indicative part of how we go ahead and flight test and field assets here for the Air Force. So with that final year's project, really put all of your effort in to seeing your project through, and that'll set you up well for the future. So how does aerospace engineering look here at Edwards Air Force Base? There are so many groups here that utilize aerospace engineers and really the STEM field in general. So if you're not necessarily interested in aero, but you're interested in STEM, Edwards has so many incredible opportunities for you guys to partake and really be a part of the future. So obviously with Aerospace Engineering, there's structures, which is the group that I'm a part of, as well as flying qualities, flight control systems, all that good stuff. I like to think of aerospace as kind of like the skin and bones and the brains of the aircraft, and we're the ones that really help it fly. You also have engineering programs like mechanical engineering for propulsion and engines. You've got electrical engineering that really works with radars and weapon systems and telemetry, getting data real time. Software engineering, which is programming and making tools for the future. Statistics and mathematics. You've got physics and chemistry. There's really so many opportunities here at Edwards Air Force Base that are available to folks if you are interested in anything STEM related. So what do I do as an aerospace engineer? Kind of everything, I think is the fun answer to that. So we've got the unique opportunity to flight test new and modified aircraft. So new aircraft like things like the T-7, which is the new trainer aircraft that the Air Force is developing, and modified aircraft like the F-22 that I work on that's been around since the 90s. But we are continuing to modernize the aircraft so that we have the best technology out there for the Air Force. And we go through that same really 4-step process that I talked about in the senior design portion that you'll go through in college. You work to plan the test, actually test your new asset, analyze data, and report. I like to say that data is meaningless until it's been analyzed by the engineer. And that's how we go ahead and say yes or no that something is up to the requirements that we are trying to design to. So on a daily basis, when the aircraft is in the air and we are looking at this data real time, this is kind of what we go through. So this gal here, she is looking at data from the aircraft as the aircraft is flying, which is something that I only saw in movies. I didn't necessarily think it was real life. And that is truly what we do. So she is looking at strip charts of data, and the data is dependent on the discipline that is testing. So for me, as an aerospace and as a structures engineer, I'm looking at data from accelerometers, from thermocouples, strain gauges, microphones. Whatever the test is, we scope the instrumentation to make sure that we collect adequate data. And we look at the data real time. And you can see she's wearing a headset and she's got a cue in her hand where she's talking to not only her team, but the test conductor and test director to pass calls to let them know whether or not the data is good. And that is truly the heart of what we do at Edwards as a flight test facility is whether it's new or modified, it's our job to make sure that whatever we decide to provide is safe and acceptable for execution. If you look on the right-hand side there, that's the F-15 Saudi Arabia aircraft. So that was the first aircraft that I worked on when I got to Edwards Air Force Base. And this jet was absolutely incredible. So the F-15 has been around since the 70s, since 1970s, and it's still a workhorse for the Air Force. And what we did is we took that jet and turned it into a fly-by-wire, which means that we made the jet smarter and we made the jet more stable. And that allowed for the outboard wing stations, so those 2 missiles closest to the wingtips, to be utilized for the first time in over 40 years. Previously, the aircraft was not capable of carrying weapons there because it was not stable enough. So we were able to flight test this whole new configuration, and it is now the baseline for the F-15EX that the Air Force is currently testing and getting ready to field. Another fun note about the aircraft is if you notice the orange coloring, while it is really cool, it does serve a purpose. And what the flight test orange indicates is a surface that has been modified for flight test. So it is saying that we've got all new wings, we've got new vertical tails, we've got new horizontal tails, specifically for this design to, again, enable this new outboard station capability. So that program in and of itself was a lot of fun to test, and that was my very first program out here at Edwards, and it got me hooked on flight test engineering as well. These next couple aircraft here in the middle is the mighty F-22 Raptor. So that is where I currently am working. I am the structures lead on the F-22 program, and I lead a team of about a dozen engineers as we test various new capabilities for the Raptor. So we're making the aircraft smarter, we're making it more capable, we're giving it new weapons, all of that good stuff. We are continuing to advance the F-22 as well as other platforms here like the F-35, the F-15, the F-16. All the fighters are going through a modernization effort so that way we can keep up to speed with the rest of the world. And like I said, with the opportunities here at Edwards, we've got not only fighters, we've got tankers and weapon systems and bombers and all of that good stuff, drones. So anything and everything that flies that is run through the Air Force comes through Edwards. And we've got the opportunity as engineers to work on all of them. And that is just, to me, the coolest thing. If you have any questions at all about any of the projects I've worked or how to really work on different platforms, go ahead and text them in. I'd be happy to talk more about what I specifically do on some of those projects if you guys are interested. All right, and the last thing I wanted to talk to you guys about is how to get involved in engineering. So if it's something that really interests you, but you've never really heard about it or been involved in outreach programs, what I would really encourage you guys to do is start looking into different engineering organizations. So I've listed a few there that I'm a part of, but there are so many out there that actually helps provide outreach events to the local communities. And to different schools and all of that. So things like AIAA and Women in Aviation and the Society of Women Engineers and SHIP, it's all great organizations that will help not only run engineering challenges that you can be a part of, but they write like newsletters and articles about different engineering initiatives and how engineering is changing for the future. And that's something that we obviously need your help with, is really coming up with new and innovative ideas, and you guys are going to be a big part of that. And the last thing that I wanted to really bring up are some of the opportunities that Edwards offers. So if engineering and aerospace and STEM is something that you guys are interested in, Edwards offers multiple different scholarships to help not only get you guys in the door and have you guys be a part of what we do, but also help fund your education. So things to consider are different scholarships and outreach events, like I mentioned. And for example, we had an intern over at F-22 this summer, and she was an integral part of our flight test team, and we had her for 3 months. She was directly working with the mission. We sent her back to school, and she's going to come work with us full time when she graduates. So definitely take a look at scholarships and also take a look at different engineering organizations to get involved. If you guys have any questions with regards to outreach events, reach out to your counselors and to your advisors, and they'll be able to help point you in the right direction for Edwards and for aerospace engineering opportunities. And with that, that is the end of my presentation. So thank you guys for sticking along with me. Hopefully I was able to shed some light on aerospace engineering and what we do here at Edwards. If you have any questions, go ahead and text them in, and I'll be happy to answer any that you guys may have.
Ma'am, one question we've had is, what inspired you to follow your current area of study?
So my current area of study I've always loved planes, and I've loved test more than design. And that's something that I found out early on. I love being able to see and feel and influence directly what I'm working on. And that is what testing is. So I wanted to test airplanes, and Edwards is the place to do that.
Thank you, ma'am. Another one we've had is, what is your favorite part of your job?
So my favorite part of my job, like I said, is being able to walk out of my office and see F-22s on the flight line, to be able to walk up to the jet and say, holy cow, that's what I work on. I am directly influencing how this aircraft is going to advance into the future. Here at Edwards, we have a lot of sonic booms, and you're constantly reminded of the awesome air power that we have. Really just being able to see and touch and feel and work with an incredible team to work on these aircraft and advance it for the future. I think that is just the neatest thing, and especially as a young engineer, to have that much influence, it's very empowering, and it's really cool to work on.
When you were young, did you expect to have the job that you have now?
Oh man, when I was a kid, I thought I was going to be an astronaut, or I thought I was going to be a doctor. I really had no idea about the test world and about aerospace engineering till I got into high school. So I think growing up, I had big, lofty dreams, which were awesome. And as I grew up and developed and figured out really what I wanted to do technically, that's kind of how aerospace engineering manifested itself in my life.
Looking back, are there any decisions that really helped you along the way to your career?
So looking back, I think one of the biggest things I want to encourage folks is to not settle or to not compromise what you want to do technically. So like I mentioned, I played golf in college, and I could have very easily picked an easier degree field based on how intense my athletic expectations and involvement was. And I told myself that I was going to school first for academics and second for athletics. And academics were going to be my number one priority. And that really allowed me to kind of develop a lot of skills that I didn't know I had, juggling both academics and athletics. But I'm really proud of the fact that I didn't compromise in what I wanted to do. And I'm extremely, extremely grateful to have the opportunity now that I do, because I kept true to what I wanted with aerospace engineering growing up.
Thank you, ma'am. Another question we got was, besides curriculum content, what are some of the things that we learn in our school age years that will matter later?
So I think just developing your own skill set and what works best for you in terms of organizational skills, in terms of how you prioritize work, of how you work best. Just figuring out how you are most successful and just continuing to grow and learn how to develop those skills on top of your technical abilities, which will come. A lot of it's your personal skills and, working with a team and staying on top of all of the tasks that you have. I'd really work on that as well.
Ma'am, did you ever get discouraged along the road to your current profession? And if so, what helped you along the way?
Yeah, there's always speed bumps. There are courses that you may not understand nearly as well as others. There may be projects and homework assignments that are more difficult that you really just don't get. I think what I would say is never be afraid to ask for help. There's no shame in asking for help from a professor, from a tutor, from a student, from parents. Always ask for help and be willing to learn with an open mind. Sometimes the way some things are taught don't really work, but there are different ways to communicate to folks. And figuring out if you're a visual learner versus an auditory learner, and like I said, different ways that you can learn, I would always ask for help, and you'll get through it. Just be persistent and never give up, and you'll get through those speed bumps.
Thank you, ma'am. Besides, obviously, the F-22, what is the most exciting thing you've worked on?
Oh, man, I was going to say the F-22. I think Honestly, the F-15 was great, but like I said before, being able to take a look at these incredible fighters or bombers or tankers, whatever you're working on, and being able to walk out to the jet and know exactly what the jet's doing and know exactly what you're trying to get it to do to get the data that you need. I think it's extremely exciting to be able to say, I know exactly what's going on, and I know how we're going to improve it for the future.
Thank you. And what is the most surprising thing you've learned on your job?
I think the most surprising thing is that we're all extremely capable, and you're going to surprise yourself in what you can do. We throw a lot of opportunities everyone's way, and it's up to us to really succeed for the mission, and we all succeed. I think you're going to be challenged, and you're going to do extremely well. And I wasn't expecting to have the opportunities that I did at such a young age. And I think that the trust that folks give to us and the opportunities that we have really help develop everyone technically, which is super neat.
Awesome. One question we had was, what invention or technology would you like most to see implemented?
Oh, that's a tough one because inventions to me are just absolutely incredible. I think we have so many new technologies nowadays that really help streamline how we work. So I think what I would really like to see specifically for Edwards or for what we do for flight test is I want to be able to directly analyze and influence data. Right now, there's a delay from when we see things into the control room to when we are able to really analyze data post-flight. I think if we have a capability to do all of that kind of at once, that'll really help us push through a bunch of new modernization efforts, really cut down on our timeline.
Thank you, ma'am. One question. What can youth today preparing for the job market of tomorrow do in order to prepare for rewarding employment opportunities?
So I think kind of what I've mentioned before is just be persistent and approach everything with an open mind. I think you're going to have a lot of opportunities come your way that you don't know you're going to love until you start working it. So don't ever be afraid. Go into everything with an open mind. And work your hardest, and you're going to find out that you're a lot more capable than you think, and the job's going to be a lot cooler than you could even imagine.
Thank you, ma'am. What were your most challenging classes in college and in high school?
So I think in high school, my most challenging class was probably my chemistry and biology classes. My brain doesn't really work that way. I work in numbers, and that to me was really challenging, but I loved it for the challenge. And in college, my most challenging courses were a lot of my space classes, trying to imagine orbital trajectories and how things worked up in space was, again, very challenging, but I was able to figure out ways that I was able to receive the information and kind of work through a lot of those challenges with my professors.
Thank you, ma'am. One question was, do you think commercial transportation to space will become a reality in our lifetime?
Oh, I hope so. That'd be so neat. I think just like how the aeronautics world is ever progressing, so is the astro world. Space travel seems like it's becoming more and more of a reality with all of the new companies that are coming up with innovative methods to get folks into space. And I hope so, at least. I think that would be just absolutely incredible for us to be able to attain.
Do you think that lunar or space habitation will become a reality for the general public?
Potentially. That is probably a little bit further away than just space travel. For the population, I think that there's a lot that we need to learn through, and I think a lot of really incredible minds are on the task to try and make that a possibility. And we're going to need the help from the next generations to come to really help push that into reality.
What advice would you give to students who would like to pursue a career in aviation or engineering?
I would just say get involved and start working projects and challenges. Really try and figure out what part of aviation you work well in and interests you. I personally love structures. That's ever since I took those classes in college, I knew that this was my path. But it took trial and error to get there. So I would say just approach everything with an open mind and start working a lot of hands-on challenges to see what you're interested in.
One question we got was, who did you look up to as a child?
Well, as a kid, I think probably my parents. Both of them were absolutely influential in my career, both technically and with golf. They always encouraged me to do my best. And because of that, and wanting to pursue a degree that they weren't familiar with, they gave me the opportunities to talk to the right people to figure out if engineering was for me. So I'm really thankful for that and for them.
Is it possible for you to tell us in detail about a test that you worked on?
Yeah, so for the F-15, I was given the noise and vibration project. And so I was able to design multiple tests for various configurations to collect both microphone and accelerometer data to see how the new store configurations were influencing the vibration environment on the aircraft. So we were really concerned with things like acoustic fatigue and acoustic cycling, where we were breaking things off the aircraft because of this new outer mold line, basically aerodynamic effect. And through a lot of the high speed testing, which is really fun going out to Mach 2, we were able to safely clear an envelope, and we were also able to provide data for future test efforts on how they could better both configure the aircraft and test the new configurations.
What would you consider your greatest accomplishment?
Oh, I think my greatest accomplishment, or what I take most pride in, is how I've been able to influence my team. I have an incredible team at F-22 who are technically gifted in different ways. And we've been able to form a really cohesive bond to execute a lot of high-profile test efforts for the F-22. And I really enjoy the team atmosphere. A lot of engineering can be just by yourself with the numbers and the ones and twos. But when you work as a team and you see a whole test effort come together, I think that's the best feeling, really.
What kind of a relationship do the test engineers have with the maintenance personnel on the aircraft?
So I worked a lot of ground tests over at F-22, and I tried my best, at least, and what I've tried to tell my team as well, is to get to know everybody. We're only as smart, as we can be if we work in a bubble. So getting to really know the maintenance personnel, the instrumentation personnel, I think that's really critical to be able to do a really well-rounded job and to be able to analyze all of the different risks that we're putting the aircraft in sufficiently versus just what I'm thinking for numbers and all of that. So I really enjoy working